In this lesson, we're going to learn about similar triangles. We're going to learn how to identify similar triangles and also identify the scale factor of two similar triangles. So first of all, similar shapes are a result of dilations. They are the same shape, but possibly a different size. So in order for two shapes to be similar, corresponding angles have to be congruent, and the ratios of corresponding sides are proportional. Now remember, corresponding just simply means the same location or the same position. So let's talk about corresponding parts of triangles. We have three angles and we have three sides. Here is our similarity statement. It says triangle ABC is similar to triangle PQR. So what I like to do is I like to take my similarity statement and write it vertically. ABC is being compared to PQR. This way I can see the angles that line up are corresponding as well as the sides that line up are corresponding. So for example, angle A is congruent to angle P, because remember, similar shapes have congruent corresponding angles. Then I can see that angle B is congruent to angle Q. And then lastly, we have angle C is congruent to angle R. So let's note these. We said A and P are congruent. We also have angle B and angle Q. These are congruent and they are corresponding. And then lastly, angle C and angle R are congruent. Now let's take a look at our corresponding sides. I'm going to erase this right quick. Okay, so we have AB corresponds to PQ. Now, they are not congruent. Side AB is similar to PQ. We also have BC is similar to QR. And then lastly, we have AC is similar to PR. So it's easy to see in your similarity statement those parts that are corresponding. And to be similar, remember, corresponding angles must be congruent, while corresponding sides have to be proportionate, which we will get to. Let's talk about our constant ratio. This is our scale factor. Remember, scale factor, we use the variable K, and it's the new length compared to the previous length. So we have our new image, and I'm going to write the word image here. So it's the image compared to the pre-image, or we could say the new compared to the old. Now remember, if our K, our scale factor, is more than 1, we have made an enlargement. If our K factor, our multiplier of all sides, is between 0 and 1, we have made a reduction. And if K is simply 1, we have just made a duplicate shape. So let's see if these triangles are similar. Again, I'm going to line up my corresponding parts, and let's see if we do have congruent angles and ratios that are proportional about the sides. So let's see, we have angle A and angle P. So angle A is 78 and angle P is 78. So far so good. Then we have angle B, it needs to be congruent to angle Q, and B is 68, and Q, we don't know. So the way we can figure that out, we know that a triangle is 180 degrees. So we're going to have 180, and we're going to subtract the total of 78 and 34. So 78 and 34 gives us 112. And then we subtract that from 180 and we get 68. So this is 68. So we have that. That is true. And then we need angle C to be congruent to angle R and angle C. So we need to add up 78 and 68. And that gives us 146. So we're going to subtract out 146. And we're going to get 34. So this angle is 34. So C and R are 34 degrees. Okay, so we have met the criteria that the corresponding angles need to be congruent. Now let's talk about the sides. We're going to compare AB to PQ. We're going to compare BC to QR, and then we're going to compare AC to PR. So AB is 12, PQ is 8, BC is 24, QR is 16, AC is 18, and PR is 12. So now we're going to simplify these. These have a common factor of 4. These have a common factor of 8. And these have a common factor of 6. So you can see they have a constant ratio, and therefore these two triangles are similar. Our scale factor, if we went from the small to the large, our scale factor would be 3/2. But if we started out with ABC as the pre-image and we went to PQR, then our scale factor would be 2/3. So always note which one is the image and which one is the pre-image when given the scale factor. Now let's see if these are similar. So we have triangle XYZ and we're comparing it to MNO. Are these similar? So our angles would be X needs to be congruent to angle M. Angle Y needs to be congruent to angle N. And angle Z needs to be congruent to angle O. X is 84, M, so we're going to add these up. So we have 64 plus 32 gives us 96, so our triangles are 180 degrees in all. And then we're going to subtract that out, and we get 84. So this measurement is 84. Check. Then Y, we have Y. Oh, I think we have a typo here. So this needs to be a Y down here. Okay, so we have Y, and we don't know that measurement, but we can find it out. So we're going to add up the two given triangle measurements, gives us 116. We're going to subtract that from 180, and this is going to give us 64. So angle Y is 64. So angle Y is 64 and angle N is 64. Now we have Z, which is 32, and angle O is 32. So our angles are good. Now let's check our side lengths and see if they're proportional. So X, Y is going to be compared to M, N. Then we have Y, Z being compared to N, O. And then we have X, Z compared to MO. So XY is 20, MN is 10, YZ is 32, NO is 16, XZ is 38, and MO is 18. So this simplifies to a scale factor of 2, 2, but look here, this does not simplify to 2. So we know that we could divide 2 into both of these and get 19 over 9. So because this is not a constant ratio, these are not similar. Okay, now we're going to identify the scale factor. So here's our pre-image. So it is telling us that these are similar. So I am going to write my statement vertically so I can identify all my corresponding parts. So ABC is similar to PQR, and we have angle A is congruent to angle P, and we have angle B is congruent to angle Q, and then angle C is congruent to angle R. So here we have 55 as P, so A is going to be 55. We know B and Q are both 90, so let's find angle C and angle R, their measurement. So we have 55 plus 90, so 55 and 90 is 145. So this is going to give us 35 degrees. So each of these are 35 degrees. Okay, now our scale factor, we're going to do our pre-image, and we can compare. We're going to put our image on top, so be careful with that. So we could take PQ and compare it to AB to find the scale factor. Well, really, that's the one we're going to, not that one. Okay, here's the deal, guys. Let's look at this one more time. I have 26 and 13. These are the only two where I have both measurements in this of corresponding parts. So we have to use, we're going to compare PR to AC. So we're comparing PR to AC, and PR is 13 and AC is 26. So our scale factor is 1/2. Now we can use this 1/2 to identify the missing links. So our pre-image is going to be multiplied by 1/2 to give us 12. Now we're going backward, and so we can take our scale factor and reciprocate it and multiply 5 times 2 to give us 10. So whenever you're using the true scale factor, you're multiplying the pre-image times your scale factor. If you're going backward, you have to reciprocate your scale factor. Okay, let's identify the scale factor here. First, let's identify our angles. MNO is similar to JKL, so angle M is going to be congruent to angle J. Angle N is going to be congruent to angle K. And then we have angles O and angle L congruent. So let's find these measurements. So N is 52, so K is going to be 52 degrees. J is 78, so M is going to be 78. Now to get O and L, we're going to add up the two known angle measurements and then subtract from 180. So angle O and angle L are each 50 degrees. Our triangles add up to 180. Now let's find the scale factor. So we have, let's see, we have MN and JK. So we do have JK and MN. So we're going to do the image, JK, and we're going to compare it to the pre-image, MN. So JK is 8, MN is 12. This simplifies by a factor of 4 to 2/3. So our scale factor is 2/3. So when we go from pre-image to image, we're going to multiply by 2/3. So NO, and KL correspond. So we're going to take 24 and multiply it by our scale factor. 3 goes into 24 8 times, and then 8 times 2 is 16. Now we have to get MO, so MO and JL correspond. So we're going to go backward. So we have to use the reciprocal of our scale factor, which is going to be 3/2, and we multiply it by 14. So 2 divides into 14 7 times, and then 7 times 3 is 21. So let's identify the scale factor here. So we have XYZ is similar to UVW. We have angle X is congruent to angle U. Angle Y is congruent to angle V. And then angle Z is congruent to angle W. So here we have an isosceles triangle, which means here's our two congruent lengths. So we know this is going to be 48 here. Whoops, not degrees, but 48 units. And then also, when these two sides are the same, these two angles are the same. So now we just have to find this measurement, which is given here with 70. So we know this is 70 degrees. And now we have two angles that are the same measurement. So let's subtract out the 70. And now we just have to divide this by 2, and we get 55. So these angles are all 55 degrees. Okay, now let's find our scale factor. So we have this side length and this side length. That's what we're going to have to use, that ratio. And we're going to do the new image, which is, let's see, this is going to be VW compared to YZ. VW is 24, YZ is 32. They have a greatest common factor of 8, and this is going to give us 3/4. So our scale factor is 3/4. When we're going this way, we use the scale factor as is. So we're going to take 48 and multiply it by our scale factor of 3/4. 4 divides into 48 12 times, and then 12 times 3 is 36. And then these two are the same. In this example, we're going to determine if these triangles are similar, but we're going to use this statement here. At the very least, to prove two triangles are similar, it is sufficient just to show that two angles of one triangle are congruent to two corresponding angles of the other. So if we can prove that two pairs of corresponding angles are congruent, then we can accept that these two triangles, AXYZ, is congruent to GHZ. So first of all, we're going to have angle X needs to be congruent to angle G. Angle Y needs to be congruent to angle H, and then angle Z needs to be congruent to angle Z itself. So we know this is true. Both of these are 35 degrees. Then we have angle Y and H, and we can see that they're both 90. So since we have two pairs of corresponding angles that are congruent, we can conclude that angle X and angle G are congruent. So to find their measurement, we're going to add 90 and 35, and then we're going to subtract that from 180. So 90 plus 35 is going to be 125 degrees, and then when we subtract that, we are going to get 55 degrees. So angle X is 55 degrees and angle G is 55 degrees. So now we can say that these two triangles are similar. Now let's find the scale factor and find the missing parts to the big triangle. We can see the triangle GHZ has lengths 5, 12, and 13. So the one pair of corresponding sides we have is HZ and YZ. So YZ is 24 and HZ is 12. So our scale factor is 2. So that means that GH corresponds to YX. So therefore, YX is 10. We can see that GZ is 13 and it corresponds to XZ. So XZ is 26. So again, similar shapes are the same shape but a different size according to the scale factor. Corresponding angles are congruent and corresponding sides have a constant ratio.